Good morning, good afternoon, year nines. This tells you where I am. So, good afternoon, and welcome to another wonderful math session. Today, we're going to be looking at finding the area of a rectangle. The title I would like you to write in your books is Area of a Rectangle, and this is the plan for today's lesson. So there'll be some parts where I'm talking, and then other parts where you are doing the work by yourself. If you don't have access to a computer, I would suggest, or I would recommend. There's my synonyms. I would recommend that you use your books to do the working out and to lay out the presentation as neatly as if you were in the classroom. I'm going to try and keep this clip short, so I may skip some parts. I hate when I say. Anyway, let's move on. So, part one. So the goal is understanding the formula for the area of a rectangle, and then we're going to use the formula to work out the area of said rectangle. But before we do that, let's look at how we can physically start counting or discovering the area of said rectangles. So here we are. So what is the area and how do we measure it? So the area of what is the area and how do we measure it? The area is a measure on a flat surface. So for example, if I was to have this paper, even though it's three-dimensional, but if we just look at this side of it, that would be the area, 2D. Whereas my coffee cup, that would be volume. So it's only when we're looking at a flat surface that we use the word area. So we measure area by counting the number of squares that fit inside the shape. So here's an example. The square can be any size, and we usually use squares with sides 1 centimeter long. So in this case, it's just one square. So we would say the area here is 1 square centimeters or centimeters squared because we're multiplying two dimensions. So we're multiplying this value here on top and this value here on the side. Okay, that's why it's 2. We're multiplying two values. If it was 3 volume, then it would be 3, but it's just 2. We can also use square meters or meters squared, which are squares with sides 1 meter long. They're used for measuring larger areas. Okay, so here's an example. Let's look at why or how we would work out the area of the following two shapes. So we have shape 1 and shape 2. So we have shape 1 over here on the left hand side and another shape, shape 2, on the right hand side. And the question is, which one is bigger? Yeah, it's difficult. So it's very difficult to say. However, if we were to divide each one by an equal amount of squares, centimeters squared, we can now look at which one is bigger. So let's look at, let's click on and start counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one is 11 squares or 11 centimeters squared because each square is 1 centimeter by 1 centimeter. Or we have this shape here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we can say with some definitive answer that shape 2 is bigger because it's 12 centimeters squared. Here's another one, a favorite of mine. Looking at this hand, which one's bigger? What is the area of the palm of our hand? And again, we could click on this and we could find out what the area is. So what I would like you to do is pause the clip and work out the area for each one. Okay, so let's count the squares. So 1, 2, 3, 4. This one is 4 centimeters squared. This one is 1, 2, plus 2 sides there. So that would be 3. Here we have 1, 2, 3, 4. And if we were to join these two together, that would make one full square. So that would give us 1, 2, 3, 4, 5. Here we have three full squares. 1, 2, 3. We have half a triangle and a half a triangle there. If we join them, that'll give us one full square, and then we have the same here. So altogether, that will give us 5 squares. On this one, we have 1, 2, 3, 4, 5. Okay, 6, and then we have that will give us one full triangle, another full triangle. So now if we add it all together, that would be 1, 2, 3, 4, 5, 6, 7, those two together 8. And let's mark it. You should have those answers. And again, you may find that counting all those squares takes a long time. Um, it takes a long time. You may find that counting those squares takes some time. And math is all about being efficient. Is there a quicker way that we can do this? Well, there is. If we look at this shape here, we have 5 squares along this side and 4 squares along that side. So that means we have 4. That's 4 there. So that's 4 there. That's 8. That would be 12. That would be 16. And that would be 20. And again, if we look at the connection or the relationship between the numbers we have here, the 5 and 4, and the number of squares, we can see that we can just multiply the 5 and the 4. I hope you can see it. Not we. I hope you can see that if I multiply 5 and 4, I would have a similar result. So let's move on. So how many squares are there in each row? We said there was 4 squares. How many rows of 4s are there? Well, there's 5 rows. And we could just multiply 5 times 4 to give us 20 squares. And the formula for finding the area of a rectangle is length times width. So the length multiplied by the width. So what I would like you to do is have a go at these 3 questions, pause the clip and try yourself using the formula the area length times width. So if you do 4 times 6, that would give us 24. And if we have 2 times 8, that would give us 16. And if we have 4 times 3, that would give us 12. Now, if you count each square, you will find that it all adds up to 24. Let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And we can be certain that if we're comfortable with our times tables, we'll be comfortable with our solutions. So let's try this area, the area of this rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And the final one, 4 times 3 should be 12. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if we mark it, you should have 3 out of 3. Now here's another example. Okay, so we'll up the challenge. So the area of this rectangle is 35 squares. However, we don't have a length. We know that the width is 5 centimeters, but we don't know how tall it is. So what can we do there? What can we do? If you think back to your times tables, you can ask yourself 5 times what will give you 35. So that's the formula. Area is length times width. We know the area is 35 centimeters squared. However, we need to ask ourselves a number multiplied by 5 to give us 35. What could that number be? Do you have a solution? Okay, So we can use we can do 35 divided by 5, and that would be 7. So the length of our this particular shape, its length or rectangle, its length is 7 centimeters. Pause the clip and have a go at these questions, and let's see what you come up with. Pause and try. Okay, so let's work out. So we have 7 times 3, which is, yeah, 21. We have, I'm going to do it this way. We have, I'm going to go horizontal. We have 8 times 2, which is 16. We have 3 times 3, which is 9. I've left the green one there for the challenge. We have the following scenario, situation. I'm really good at my synonyms. I hope I am. It sounds good in my head before I say it out loud. Anyway, we have 6 times the number to give us 18. So 6 times something to give us 18. Yeah, I did clap. 6 times something to give us 18. What could that be? What number? Timetables. Yeah, yeah. So 6 plus 6 is 12, plus 6 is 18. So 6 times what to give us 18? Yes, 3. So the width here is going to be 3 centimeters long. And if we mark our work, you should have 4 out of 4. Okay, to give you an individual task, have a go at the following. Pause the clip to give you some time. Pause the clip, have a go at these questions, and you can do it any way you want. You can count the squares or you can use the formula. Okay, so if we count the squares, we have 1, 2, 3, 4. So the width is 4 and the length 1, 2, 3, 4, 5. So 5 times 4, 20. Here we have 1, 2, 3, 4, 1, 2. So 4 times 2 is 8. So the area here is 8 centimeters squared. Interesting. We have a triangle here, and we're trying to work out what the area is. So what we could do is we can count the squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I've lost my train of count. Or alternatively, we could work out the area of a full rectangle and then divide that by 2, because this would be a half of a um, rectangle. That will be another lesson. For now, yes, for now, let's put the answer in. 1, 2, 3, 4. 1, 2, 3, 4, 5. So 5 times 4 is 20. 20 divided by 2, because it's half a rectangle, is 10. Try with this one and see what you get. So 1, 2. So its height is 2. So 1, 2. And going along, it's 1, 2, 3, 4, 5. 5 times 2 is 10. 10 divided by 2, 5. So the area here is 5 centimeters squared. And finally, something you're familiar with, 1, 2, 3, 4, 5. 1, 2, 3. 5 times 3, 15. Okay, so pause the clip, and now I'm going to give you a final task for you to have a go at. Yeah, the plenary of the lesson. Okay, so to finish off the lesson, what I would like you to do is have a go at this set of questions. Pause the clip and work it out. Okay, so you should have 8 times 2, which would be 16. Then we have 3 times 3, which is 9. Then we have 8 times 1, which is 8. And finally, we need to think outside the box. So 9 times what will give you 36? So 9 times what? Times tables. So we have our if we do 36, 36 divided by 9, that would give us 4. So the solution, the width there is going to be 4 centimeters along. Final task. Final task that I would like you to do to finish off the lesson is I would like you to go on to Haggerty Maths and complete the homework that I've set you on working the area of rectangles. Any questions, any comments? I'm on the other side of the screen. Email me and I will answer your questions as much as I can. Enjoy the lesson. All the best and see you when the lesson starts. Hasta luego.